This illustration shows what the Trappist-1 system might look like from a vantage point near planet Trappist-1 effort right. Image caption credit NASA Caltech. The red dwarf star Trappist-1 and its 7 known planets have been around far longer than the Solar System, according to a new study by scientists who have estimated the system's age. Small and dim, low-mass red dwarf stars have lifespans longer than the age of the universe, which is approximately 13.7 billion years old. In contrast, Sun-like stars have lifespans of about 10 billion years. The Trappist-1 system, approximately 40 light-years from Earth, was discovered earlier this year through data returned by the Transients Planets and Planetesimals Small Telescope TRAPPIST in Chile, along with observations conducted by NASA's Spitzer Space Telescope and several ground-based telescopes. Of the 6 Earth-sized planets found orbiting Trappist-1, 3 are located in its habitable zone, where temperatures would allow liquid water to exist on the surfaces. Young red dwarf stars are very active and frequently undergo flares that release high-energy radiation. That radiation can strip the atmospheres of orbiting planets, destabilize their orbits, and make them inhospitable to life. Based on the size of Trappist-1, scientists knew the system had to be at minimum 500 million years old. This is because low-mass stars take that long to contract enough to reach their ultimate sizes, slightly larger than Jupiter. However, without an upper limit on the system's age, there was no way to know whether the planets had survived early radiation exposure with intact atmospheres and stable orbits or had enough time for life to develop and evolve. Illustration of the Sun compared with the Trappist-1 star. The red dwarf is slightly larger than the planet Jupiter. Image credit ESA. In an effort to answer these questions, scientists Adam Bergasser of the University of California in San Diego, and Eric Mamajek, a deputy program scientist in NASA's Exoplanet Exploration Program at the agency's Jet Propulsion Laboratory JPL in Pasadena, California, attempted to determine Trappist-1's age. The researchers looked at various factors commonly used to discover the age of a star, including measurement of its speed in orbiting the galaxy, the chemical composition of its atmosphere, and the rate of its stellar flares. A star's orbital speed is important because older stars are known to travel at faster speeds. These indicators revealed Trappist-1 to be a surprisingly old system. Bergasser and Mamajek estimate its age to range from 5.4 to 9.8 billion years. In contrast, the Solar System is about 4.5 billion years old. Our results really help constrain the evolution of the Trappist-1 system because the system has to have persisted for billions of years. This means the planets had to evolve together, otherwise, the system would have fallen apart long ago, Bergasser said. Trappist-1 is currently quiet in comparison with other red dwarfs, a trait consistent with its older age. Knowing the system's age still does not tell scientists whether the planets are habitable. Because of their close orbits, all are likely tidally locked to the star, meaning one side always faces Trappist-1 while the other always faces away from it. Although the planets survived the frequent flares that occurred during the star's early years, the impact of those flares on them remains unknown. Radiation from those flares could have left the 7 worlds with conditions similar to those of either Venus or Mars in the Solar System. If the Trappist-1 worlds, all of which have lower densities than Earth, have successfully held on to thick atmospheres containing volatile molecules such as water, then those atmospheres would have protected them from the ultraviolet radiation produced by stellar flares, as well as distributed heat to the sides facing away from the star, increasing the potential habitability. However, thick atmospheres could also have resulted in a runaway greenhouse effect, as happened on Venus, making the planet too hot for life. On the other hand, over billions of years, high levels of radiation could have boiled off the atmospheres and any water on all but the furthest worlds, Trappist-1 and Trappist-1H, in a process similar to that believed to have occurred on Mars. If there is life on these planets, I would speculate that it has to be hardy life because it has to be able to survive some potentially dire scenarios for billions of years, Bergasser said. Additional observations of the system will be conducted using NASA's Hubble Space Telescope, Spitzer Space Telescope, and James Webb Space Telescope JWST. The latter is scheduled for launch in 2018. Scientists hope these observations will reveal whether the planets have atmospheres, the composition of those atmospheres, and the planet's densities. The findings of Burgasser and Mamajek's study will be published in the Astrophysical Journal. Trappist-1 is an ultra-cool dwarf star in the constellation Aquarius, and its 7 planets orbit very close to it. Image caption credit NASA Caltech tagged exoplanet Spitzer Space Telescope. The range Trappist-1 Laurel Kornfeld is an amateur astronomer and freelance writer from Highland Park, NJ, who enjoys writing about astronomy and planetary science. She studied journalism at Douglas College, Rutgers University, and earned a graduate certificate of science from Swinburne University's Astronomy Online program. Her writings have been published online in the Atlantic Astronomy magazine's guest blog section, the UK Space Conference, the 2009 IU General Assembly newspaper, the Space Reporter, and newsletters of various astronomy clubs. She is a member of the Cranfoot, NJ-based Amateur Astronomers, Inc. Especially interested in the outer solar system, Laurel gave a brief presentation at the 2008 Great Planet Debate held at the Johns Hopkins University Applied Physics Lab in Laurel, MD.